All right, number 7 from your study guide. I'm not going to read the whole thing out loud, but I'll read the different pieces. Basically, it wants you to find a function, has a couple of vertical asymptotes, has a hole. It asks you where the horizontal asymptote is for that, and then it asks you to change the horizontal asymptote. So let's start with the first part. I want a vertical asymptote at x equal to 3 and x equal to 2. It also tells me we want a hole at x equal to 1. So let's start by doing that, and then we'll answer the other questions. F of x equals, there are kind of 3 things that you have to have in this particular question to get the vertical asymptotes right here and to get the hole. In order to get vertical asymptotes, you should know that we need to have a 0 in the bottom. So for example, if I have x minus 3 in the bottom of my fraction here, that is going to give me a vertical asymptote at x equal to 3, because when I plug in when I plug in 3, when I plug in this guy right there, whatever this number up here is, it doesn't matter. Well, kind of doesn't matter. Mostly doesn't matter unless it's 0. It gives me something over 0, which is undefined, which gives me asymptote. You should know that from before. So back to blue. Similarly, if I want to have the 2, I also need to have an x minus 2. Now, from there, if I were to just put 1 over that, and it would totally satisfy the vertical asymptotes. I got to take care of the hole as well. To take care of the hole, I need to have an x minus 1 in the top and in the bottom. X minus 1 comes from that. If I have 0 in the top and 0 in the bottom, then it basically erases that function at 0. That would give me what we've called removable discontinuity at that x equal to 1. We've talked about that quite a bit. So this is probably the most basic form that you can come up with. This particular equation has a horizontal. Well, it's pretty clear that the horizontal, or so at the bottom, is x cubed in the biggest, and the top is x in the biggest power. So that x cubed will come from multiplying all 3 of those x's. I'd have other terms too, but all I care about is the biggest one. Clearly, the bottom would grow faster, which would make my horizontal asymptote at y equal to 0. It would be that flat. Its limit as x approaches infinity or negative infinity is 0. If I were to put something like an x squared, then that's going to change it, because I would have x cubed factor growth on the top and on the bottom. That actually kind of leads us into the next part of the question, which is how can you rewrite the function to have a horizontal asymptote of 4? The other info must stay the same. So what we do is this will give me a horizontal asymptote of 1. Actually, here's what I'm going to do. So the blue is the answer to the first one. I'll add an orange here. If I add 4x squared, what that does is makes the top, so it makes the top a 4x cubed plus blah blah blah. I don't care what the blah 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 is. It's really just minus 4x squared. And then the bottom is x cubed plus blah blah blah. I simply take the biggest 2 coefficients of each of them, which are cubes, and the biggest powers, and divide the coefficients. This is a 1. 4 over 1 gives me 4. So in this form, with that orange stuff, it would give me the horizontal asymptote at 4. That's that.